Hello and welcome back. In this video I will be talking about derivatives. I will be going over the derivation of the define the definition of derivatives followed by the interpretations. Lastly, I will end this video with a few examples. So let's start. First, what is a derivative? Derivatives pretty much are instantaneous changes at a given point. So instantaneous changes means you have to find a tangent. And when we talk about tangents, we usually refer to slopes. So let's do a recap on slopes. A quick recap. So say we have a point P, and we want to find, if you want to find the tangent at P, we will pick a point Q, arbitrary point Q, which is pretty close to P. So the slope would be M equals delta y, change in y, over the change in x. And the change in y is f at x minus f at a all over x minus a, which is a change in x. But this, if you can see, it's more of like a secant. We want a tangent. So in order for this to be a tangent, this is secant. I think I spelled it wrong. For it to be a tangent, we need to take this point Q and bring it closer and closer and closer to P. And so turning x into a. So we can use limits to do that. So say if we put lim as x approaches a, f at x minus f at a all over x minus a. This will give us the slope of a tangent at point P. So now since we know that, we can use that to find the definition of derivatives. So say we have point Q here, and it's say a distance delta x away. And basically, if I recall from the last one, slope of a tangent was lim as x approaches a, f at x minus f at a all over x minus a. So if you're adding delta x, that means delta x has to approach 0. And the 2 points are a and a plus delta x. So let's put that in. So limit as delta x approaches 0, f at a plus delta x minus f at a all over a plus delta x minus a. And as you can see that a's will cancel out. So we are left with lim delta x approaches 0, f at a plus delta x minus f at a all over delta x. So delta x is kind of like too long, so we can like simplify it by letting delta x equals h, and this will give us a definition of derivatives, which is lim uh, as h approaches 0, replacing delta x, which h is f a plus h minus f at a all over h. This is like the definition of derivatives, and we usually make it equal to f prime at a. And so what can we interpret out of this? First is that this is gives the slope of a tangent at a given point. So in this case, this will give the slope of a tangent at point A. So slope of tangent. So pretty much at a given point at A. And we can also interpret that this is the instantaneous rate of change. If you think about it, we are finding the instantaneous velocity. If say if you have an example of distance, we're finding the and time, and we take the derivatives, we are finding the instantaneous velocity at that time. So instantaneous rate of change. And yeah, that's pretty much it. And this is instantaneous rate of change with respect to x equals a. So let's go towards an example, because that's always easy. And oh, one more thing. Using the definition, you can find any derivatives. This is pretty much the core of finding all derivatives. And So this is our first example. Find the tangent equation to the function f of x at equals x squared plus 4x plus 1 at x equals 8. So the first thing we want is f at 3. So f at 3 equals 3 squared plus 3 times 3 plus 1, which gives us 22. 9 plus 12 plus 1, that's 22. Then we use the definition of derivatives. So f prime at 3 equals f 3 plus h minus f at 3 all over h. Oh, I forgot the lim. It's important to put this. So as lim h approaches 0, we can sub these values in, and that will give us 3 plus h squared plus 4 times 3 plus h plus 1 minus 22 that we found this f at 3 all over h. And if we expand these, we will get 9 plus 6h plus h squared plus 12 plus 4h plus 1 minus 22 all over h. And as you can see, if you add 9 plus 12 plus 1 minus 22, they will all cancel out and give you 0. So we can take this out right now to simplify it. So lim as h approaches 0. Now it's going to look pretty neat. Collect the like terms. 6 plus h, that's 10h plus h squared, and everything else cancels out. 10h. Now, before we could not sub, like in the beginning we could not sub h equals 0 because that's going to give us an undefined value. But now we can, because we can cancel the h's and sub it in. So lim as h approaches 0, 10 plus h. And if we sub h equals 0, we get 10. So therefore, the slope m10, the slope of the tangent, which is f prime at 3, equals 10. So, but we are looking for tangent equation key. So the equation of the tangent is y equals mx plus b. We already know the m and we know the two values, so we just need to find the b now. So that's it's gonna be 22 equals 10, the slope, times 3, the x value, plus b. This will equal 30. 22 plus b, and that will give us a value of minus 8 equals b. Therefore, our final answer is the tangent equation is y equals 10x minus 8. Yeah, I did this right. So the next thing is I'm going to give you an example for you guys to do. So gonna skip to here. So here's the example. Pause the video and you need to find the same thing as last time, tangent equation to f of x, the function 3x plus 6 over x at point 2 over 6. And you can pause the video. Okay, so here's the answer. Okay. Thank you for watching, and please visit aohl.info to view more videos like this. Please like this video, and yeah, hope you guys learned something. Goodbye.